Hello and welcome to part 2 of the Python Bootcamp. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. This episode, we're going to be looking at if statements. We're going to be finally getting past just Python as a simple calculator to more complex statements. And if statements are the first step to get there. Now, if statements are a fairly awesome tool. They allow you to do fairly complex logic pretty simply. So without further ado, let's jump over the Jupyter notebook and we will get started learning how to use if-else statements. Okay, over in Jupyter, you can see we have our template up. If you weren't following in the previous video, don't worry about it. Go ahead. This GitHub link right here, I'm also going to put it in the description. This is where you're going to be able to get those templates and those solutions. Now, if you didn't tune into the very first video about variables and you don't have a sense of what variables are in Python, highly recommend you go over there and check that out before you jump into this one because you may be a little lost. But we are going to assume that you've watched that before or you at least have an understanding of the simple building blocks of Python. So we're going to be focusing on if-else statements. In the GitHub link, there's a folder with a template for if statements, so grab that one and we will go ahead and get started. So 3 sections here. We're going to be looking at conditional statements for the first 2. And conditional statements are really the fundamental thing that you need to use for if statements. They're really how if statements get their power and how they actually work. So let's stop talking about it and go ahead and start learning what they actually are. So conditional statements are comparing 2 things or 2 or more things. So the first and probably the most simplest would be the equals. So we're just going to compare if 2 things are equal to each other. Now for assigning variables, for instance, if we had x is equal to 1, we had a single equal sign. But when we start looking at conditional statements, in order to separate them, we're going to use a double equals. This is going to signal to the interpreter that, hey, we are comparing these 2, we're not assigning it. So if I had 1 equals 1, this is going to return a true or false value whether or not the condition is met. So if I print 1 equals 1, obviously these are the same, so it will return a bool, and you hopefully remember that from the last episode, but a bool is true or false value, and this is true. Now if I change this, I'm just going to copy this, bring this down here, and now I say is 1 equal to 2. It's going to obviously give me a false because they're not. Not only can you compare numbers, but you can also compare strings as well. So if I paste this in here, now I want to say is red equal to red. Obviously it is. It will give me a true. Now something to be careful of, if I copy this one last time and I change one of these to be a capital R, this has now changed the strings. They are no longer equal, and you can see that by running the code. This is now false. That is because red has a different value for this capital R than it does for the lowercase r. So got to be careful of that. And we can get into how we change those strings to make it a little more complex and a little more easy to do those comparisons regardless of what's passed in. But for now, we're not going to cover that. We're just doing basic stuff right now. Okay, so that's easy. Those are equals. We can move on to not equal. Sometimes you want to compare if 2 things are different. So like we had before, I'm actually just going to copy everything in the previous cell we had up here, and I'm just going to paste it. I'm going to delete some white space. But what we're going to do is we're going to swap the first equals with an exclamation mark. So exclamation mark equal means does not equal. Now when we run these, obviously the first one, 1 does not equal 1, will come up false because 1 does equal 1. The second one will come up true. Third one, red equals red, so this is not true when we're looking at the does not equal. And last one will be true as well. So the opposite of equals, hopefully that's pretty intuitive. It's just really learning the syntax that exclamation equals means does not equal versus equals equals. All right, moving on. Again, these are all going to be fairly simple, I hope, because they're, besides the exclamation mark equals, they're all fairly intuitive. Now we're looking at greater than, less than, equal to, and so we can basically do the same thing. I'm going to copy down what we did before, but I'm just going to take the top 2, so just the numbers at this point. The reason I'm doing numbers is this only applies to numbers. Now I'm using integers here, but this also works for floating points or a combination of integers and floating points. Hopefully, again, you remember from the last video what each of those are. But we can do 1 is less than 2. We can do 1 is greater than 2. Let me delete some of this here. We can also do 1 is less than equal to 1, or 1 is greater than equal to 2. So these are all just different ways of doing less than and greater than. Obviously, when you do not include the equals, it doesn't include whatever the right-hand side is. It's only less than 2. It does not include 2, but when you add the equal sign, it also does include the right-hand side. But as you can see, running these through, 1 is less than 2, that is true. 1 is not greater than 2, that's false. 1 is less than or equal to, because of that equals to, 1. And 1 is not greater than or equal to 2. So, simple ways of doing that. Now let's go on to a little more complex things here. Okay, so maybe you want to know a range of numbers, or maybe you have multiple conditions that need to be met. And so in order to do this, we have and or statements. We'll get to or in the next section, but for now we're going to focus on and. The and statement means that both conditions need to be met. So the left-hand condition and the right-hand also need to be met in order for the whole condition to be true. So if I print to the screen 1 is less than 3 and 3 is greater than 2. Okay, this is going to give us true. So let's break this down. 1 is less than 3 is going to be true. So the left-hand side is true. 3 is greater than 2. So the right-hand side is true. So the entire thing is true. Now, if I change this to say 3 is greater than 4, this is going to return a false because even though the left-hand side is still true, the right-hand side is false. So if any of them are false, it's going to make the entire statement false. Swap that back to 2, and you can obviously see it's still true. Now, that's less than or greater than. You can also do the same thing with equals to, and you can also do the same thing with strings. So if red equals red and red does not equal, remember exclamation mark equals, does not equal green, then it's going to return true because red is equal to red and red is not green. But if you say, maybe on the left hand side now, I say red is equal to capital red, again this was one of the ones I highlighted before, now we run this, the left hand side is false, making the entire thing false. Okay, another thing that this is super helpful with is if I have a value of x, maybe let's just say x is equal to 5. Really where this gets its power is I now can say, doing a print here, I can say I want x to be greater than or equal to 0, and I want x to be less than or equal to 10. This is going to say I want my variable I want to print true if my variable is between 0 and 10. That's what this statement is saying. So that's really where it comes in handy is now I have a variable and I can compare it to a whole bunch of different conditions to say, okay, is my variable in between these two values? And we're definitely going to be using this because, again, this is like the fundamental thing that if statements are built for. Okay, that covers the and. Now let's look at the or. So now I'm going to print to the screen 1 is less than 3 or 3 is greater than 7. Okay. Now what it's looking at is the left-hand side. 1 is less than 3, so the left-hand side is true. 3 is not greater than 7. The right-hand side is false. Or says if either one or both is true, then the entire thing is true. So that since this left-hand side is true, the entire thing will be true. Now, if I change the left-hand side to say 4 is less than 3, now both sides are false. This will be false. If I change the right-hand side to be true, so now the left and right are both true. Again, the entire thing will be true. Same thing as we did before. I can say print if red is equal to red, or red is equal to green. Now I'm printing if either one is true. And again, left-hand side is true, right-hand side is not, but the entire thing will be true because it's an or statement. And last thing, like we did before, maybe I have x is equal to negative, maybe I have x is equal to 5 still. Now I'm going to print if x is less than or equal to 0, or x is greater than or equal to 10. This is going to give me false because I want to know if x is less than or equal to 0 or if it's greater than or equal to 10. So anything below 0 or equal to 0 or above 10 and equal to 10. So since 5 falls within those two, right in the center, not equal to either one, both sides will be false and the entire statement will be false. Now if x was less than or equal to 6, obviously this will make it true because the left-hand side is now true. Hopefully that makes sense. But we'll go over some exercises to help you get a better understanding of how to use these. Before we do that though, let's talk about chaining conditions. So not only can you do one statement of an and or an or, now you can start looking at really large statements and putting multiple ands and ors together with conditions. So if I take this first statement here and I print that first statement, what this is saying is, and remember, parentheses matter here, so let me just make sure I have everything ready for my print. Parentheses matter here, so it's going to solve the parenthesis first. So if red is equal to red, which is true, and red is equal to green, which is false, which means since we're using an and, this entire first parenthesis is going to be false. Or, and now we're looking at the second statement. So the or means even though this first one's false, the second one could be true, and we continue on. So let's look at this second statement here. Red is equal to red. Again, capital is going to make this false. So the left-hand side is false, but since we're using an or, if capital red is equal to capital red, which it is, that's true. So this entire statement will come back as true. It's very complex logic here, so you need to really be careful what you're looking at and kind of work it through one by one in order to figure out if the entire statement is going to be true or false. Now I can also take this next one here. Okay, and maybe I have x is equal to 5 again. Okay, so now just plug in 5 for x. So if 5 is less than or equal to 0, it is not, that is false. Since we're using an and, this entire first section is false. But there's an or separating this, which means even if the left-hand side is false, the right-hand side still could be true. 5 is greater than 0, and 5 is less than 10, so this will solve to true. So you really got to step through one by one to make sure all these conditions are met in order to solve this. I'm going to throw in a little exercise right here. I gave you this statement, and I left out the ands and ors. I left out the conditions. So whether or not they're equal or less than or greater than equal to or less than equal to, not equal, all of those. I need you to plug in what those statements are, what those conditions are, in order to make all of these values in this list true. So find what the values are, or find what the conditions are to make any of these numbers plug in and be true. Take a second, and then come back and see what the actual answer is. Okay. I'm just going to assign x to be the first value. Okay, now I'm going to print out, and I'm going to just grab this whole statement right here if I can. Which I don't think it's going to let me. Oh, there it goes. Okay. Okay, so now I have my statement here, and I'm going to be replacing all of these underscores with something. There are actually multiple solutions to this, so if you did not get the same solution as I did, but it still works, like I said, there's multiple ways of solving this. I'm just going to show you the one way that or just one way to solve it. If x is greater than or equal to 0 and x is less than 9. If x is between 0 and 9, then this is going to be true. Okay, so that's going to be 0, that's going to be 1. 10 is not going to be included in there. It's going to be 4, and it's going to not be negative 30. So this solves the first two. Or sorry, the first two and the fourth. So we still need to figure out how to get 10 and negative 30 in there. Since we're using an OR, I can say if x is equal to 10, then this will take care of the 10. Now we just need to solve for that negative 30. Okay, when negative 30 is plugged in here, this last statement is going to be the one that solves it. So if negative 30 is plugged in, it cannot be equal to 10. So we need to say it does not equal 10. You can also say it's greater than 10. Doesn't really matter. Or sorry, less than 10. But now when negative 30 is plugged in here, we need to say that it's less than negative 29. And this should work for every single value that is in that list above there. I'm just going to copy this a few times here. All right, so x is equal to 1, x is equal to 10, x is equal to 4, and x is equal to negative 30. Let me get that on the screen. Now if I run this, we should get true for all of them. Like I said, this is one solution. There are multiple solutions that will solve this problem. Just make sure that you're getting true for all of those conditions, for all of these values that you plug into it. If you're not, go ahead, go back, try to see if you can find another way of solving this, or try to solve it the way I did as well. And just take some time to figure out what those conditions are. Okay, now we're really going to get into, now that we understand what conditions are and how they can be used, now is when we start talking about if statements. So if statements look like this. We have if some condition, followed by a colon. Colon's very important. We're going to do something, and the thing that we do is going to be indented under the if statement. So for this first one, I have some value of x. So if I say if x is equal to 5 again, okay, I have my variable 5. I'm going to say if x is less than 10, print the value of x. If I run this, x is less than 10, so it will print the value of x. If I change this to greater than, 5 is not greater than 10, so it will not do anything. It does not make it into this print statement. That is the whole point of ifs, is it only will do whatever's under it if the if statement is true. Okay, let me swap that back to less than. And now let's look at something else. So let's do a little bit more of a complex statement. So now if, this is also very important. So like I said before, you need to indent whatever you want to do in the if statement. So if I had another one that said print yes, let me just remove this if statement. Now I can execute 2 lines in the if statement. If I change this again to greater than 10, now neither line will be done. So whatever you want done within the if statement needs to be indented under it. If you want to return back to not using the if statement, unindent it. So push the indent back to the same line as the original one. So I'm going to do another test. If x is greater than or equal to 0 and x is less than or equal to 10. Here's where we have our multiple conditions using an and statement. So x needs to be between 0 and 10 is what this is saying. Then we are going to print x. Okay, so in this case, we have a 5. It's going to pass the first one, and it's going to also pass the second one because 5 is in between 0 and 10. So if I run this, you can see that it did print out 5 to the screen. If I had another one, maybe let's make this 10. Now I run this. 10 is not less than 10. So it does not do this first if statement, but it does do the second because of this less than or equal to 10 at the very end here. So that's really the power of if statements is you can execute code based on a condition, and you can do multiple if statements within here. Okay. There are times where if the statement is not true, you want to do something else instead. And that's what the else statement is for. So if I have x is equal to 5, maybe I have that original if statement. So if x is less than 10, I want to print, I'm just going to say yes. I'm just going to print yes to the screen. But now I'm going to have another one, and it's going to be on the same line as the if. So in line with the if statement is going to be an else statement. And the else is going to print no. Okay, let's run this. Okay, x is less than 5, so it will pass the if statement and print out yes. Notice it does not print the else statement. It only prints the if. If I change this to be 12 and run this, it does not pass the if statement, so it will automatically go do whatever is in the else. So it will automatically print no. That is, again, the power of if-else statements is you can do this complex logic. If one thing is not true, then do something else. And what I did before was if x is greater than or equal to 0 and x is less than or equal to 10. So if x is in between 0 and 10, then I'm going to print x is between 0 and 10. Let me change this to a 0. Okay, and then I'm going to say if it's not, then print x is not between 0 and 10. Alright, so running this, we have 12. 12 is not between 0 and 10. It is going to print out x is not between 0 and 10. If I change this to 8, it now is, so it will print the first statement instead. So again, ways of doing more complex testing and code execution. The last thing we will cover with if statements is the next one, which is elif. As you notice, it's a mix between else and if, purposely. So if we come down here, x is equal to 5. I have my original statement, if x is less than 10, we are going to print, let me just print x is less than 10. Okay. Now, elif is a way to do another test after the first one fails. So if it is not less than 10, check this other thing. So now I'm going to check x is greater than 10. Print x is greater than 10. I can either end it there, or I can go into an else statement. So else x is equal to 10. What this is going to do is it's going to test the first condition. Is x less than 10? In this case it is. It will print this out to the screen, and it will disregard everything else below it as part of this if statement. If it is not, so let's say x is now 12. 12 is not less than 10. It's going to skip the if. It's going to go to the elif. It's going to check, is x greater than 12, or greater than 10? And 12 is, so it will print out this one and skip the else. If I'd say x is equal to 10, x is not less than 10, it will skip this. X is not greater than 10, it will skip this, and it will print the else out. So now we're doing multiple tests. You can add in as many elif statements as you want. So you can keep testing every number if you wanted to, all the way down. But if I run this, you can see it makes it all the way to the else and says x has to be equal to 10. Okay. And then we can do our more complex logic. So x is greater than or equal to 0, and x is less than or equal to 10. Print, we're going to say x is between 0 and 10. We're going to have an elif. Now we're going to check, hey, is x less than 0? If x is less than 0, we're going to say x is less than 0. Now I'm going to have another one. Maybe elif x is greater than 10. Print x is greater than 10. Now, I'm not going to use an else. You don't have to. Just know that if any value that I put in here is not included in any of these conditions, it will not execute anything. So the else is just a catch-all. If it makes it all the way to the end, do something else. So maybe in this case, I can run this, and it will give me a value, and I know everything is covered because it can't be any other number. But just in case, maybe I want to print error or something along the lines of that, saying, hey, you failed all of these conditions when you weren't supposed to, so something happened, you need to go check your conditions again to see what happened. But again, 10 is, it passes the first one, so x is between 0 and 10 inclusive. I should put inclusive in here. Okay. So that's really all there is for if statements. What I want you to do is I want you to build this if statement out. And I want you to run these numbers for x and come up with whatever the hidden message is. So go ahead, take some time, build out these if, elif, and else statements, and come up with, if you run each of these values of x, what is the hidden message that comes out of it? Okay. So going through this, we're just going to go one by one down the line. So if x is greater than or equal to 10. Actually, you know what? I'm not even going to code this out. I'm actually going to run through these. So 1, if we go down the line, 1 is not greater than 10 or equal to 10, so move on. 1 is not less than 0 or equal to 5, move on. X is not greater than 10, move on. So I'm going to go down the list. 1 is going to solve this one right here. So 1 is greater than or equal to 0 and less than 2. So we are going to print n. I'm just going to keep track down the bottom here. 11 does not equal 11, won't work there. It is greater than 10 and less than 12. So we're going to be printing a O. 3. Working down the list. Okay, it failed every single condition all the way down the list, which means it's going to default to the else. The else is a space, so throw a space. All right, value of 2. Going down. X is equal to 2. We are going to print a B. Okay. We're at 13. X is greater than 12 and it does not equal 11, so we are going to print a U. Next is 4. X equals 4 and is not 3, so it prints out a G. Negative 2. X is less than 0 and or equals 5, so it's going to print out an S. Okay. Back to 3. If you remember, 3 back here went all the way down to the bottom and it was a space. So we're going to print out a space. We have a 6 now. A 6 is greater than or equal to 6 and less than 7. So that is true. That is an F. All right. An 11. X is greater than or equal to 10, but this one will fail because it is equal to 11, so we keep working our way down. 11 is greater than 10 and less than 12, so this will be an O. 14. It is greater than 10 and does not equal 11, so this will be a U. 8 is going to be... It is greater than 0. Nope, that's not. It is greater than or equal to 8, and it is less than or equal to 9, so this will be an N. And the very last one is a 7. So let's work our way down. It's greater than this, but is not less than 7. And as we get to the very bottom, it is not 3, and it's made it all the way down to this point, so it must be a D. So our message is no bugs found. Hopefully you were able to work your way through that and come up with it. And that is where we are going to end. If statements are, again, very powerful. They're really the way you unlock the potential of Python to be more than just the simple calculator that maybe you can use right now. So we're going to be using these in the next few videos to really go a little farther with looping and with functions. So stay tuned for that and keep up with this Python Bootcamp because it'll get you pretty far in learning the basics of Python and get you to that intermediate level to really start using Python for some more advanced data science and data analytics type things. So thanks for joining, and I'll see you in the next video.